Welcome to the RobotStudio tutorials. In this session, we'll walk through the complete workflow of creating a mechanism. As you can see on the screen, the geometry has already been imported. The base, pillar, and lift components are visible in the workspace, with their local origins aligned to the RobotStudio origin, ensuring everything is correctly positioned for mechanism creation. We begin by navigating to the Modeling tab and selecting Create Mechanism. Name the mechanism XZ Lifter. Set the mechanism type to External Axis. Keep the kinematic type as Other. Next, we define the links. A two-axis mechanism requires 3 links. Add the first link by selecting the base part and make sure it is set as the base link. Use the green arrow to add it, then click Apply. Continue by adding the pillar and lift as the remaining links. And click OK to confirm. Now we define the joints. Add the first joint and set its type to prismatic, as this is a linear motion. Define the travel direction by assigning a positive value along the x-axis. A preview line will appear to indicate the direction of motion. Set the limits from 0 to 8,000. You can test the movement by jogging the axis, then click Apply. For the second joint, verify that the parent link is L2. Again, set the type to prismatic, define the motion along the positive Z direction, and set the limits from 0 to 1,000. Test the movement and then confirm. Next, we create an attachment frame. Add a new frame and name it F1. This frame will be used to attach the robot. To position it accurately, set the selection level to surface and the snap mode to center, then select the top surface of the lift. Adjust the orientation along the Z-axis and fine-tune the position along the Y-axis as needed, then confirm. Now we complete the calibration setup. Add calibration, and since this mechanism type does not require calibration frames, set both joint values to 0. With no dependencies remaining, we can now compile the mechanism. As it compiles, the XZ Lifter becomes visible in the Layout browser. Close the dialog once the process is complete. The mechanism is now ready. Next, we test the mechanism. Open the joint jog controls and move axis 1 and axis 2 to verify the motion. Use the jump home function if needed to reset the position. Now import the ABB robot library and select the IRB 2600. Attach the robot to the XZ Lifter and confirm the update of its position and coordinate system. Jog the axis again to see how the robot follows the movement of the lifter. With this setup, the robot's working range is significantly extended. Finally, save the XZ Lifter as a RobotStudio library component for future use. You have now successfully created, tested, and integrated a custom mechanism in RobotStudio. Thank you for your time. Please subscribe for more tutorials like this.